Hey everyone, and welcome back for another deep dive. Today, we're heading to Mars. Well, not literally, of course, but we're going to get as close as we can by diving into some fascinating news from NASA about their plans to bring Martian samples back to Earth.
Sounds pretty exciting.
Oh, it is definitely exciting, especially because it seems like they're completely changing their approach.
Yeah.
So to set the stage, we've got a great article here from NBC News by science and space reporter Denise Chow. It was published on January 8th, 2025, and basically it says that NASA is overhauling their Mars sample return mission, which is kind of a big deal because this mission has been in the works for like, what, 2 decades?
Yeah, at least. I mean, it's been a long time coming and a lot of work has already gone into it. So to see them kind of shift gears now is definitely interesting.
Yeah, so maybe you can help us understand why this big change is happening. What was the problem with the original plan?
So the original plan was actually pretty complex. They were going to send a single lander to Mars, which they called the Sample Retrieval Lander. And this thing was supposed to land near the Perseverance rover, which, as you know, is already on Mars collecting samples.
Right. Perseverance has been diligently filling those little sample tubes for a while now.
Exactly. So the lander was going to scoop up those samples using a robotic arm, load them into a small rocket, and then launch them into Martian orbit. From there, a European spacecraft would grab the samples and bring them back to Earth.
Wow, that sounds incredibly complicated. Like a whole bunch of things that could go wrong.
Yeah,
Yeah.
exactly. There were concerns about the cost and just the sheer complexity of the mission. It's one thing to land a rover on Mars, but to coordinate all these different spacecraft and maneuvers and make sure those samples get back safely was a huge challenge.
So it sounds like NASA decided to go back to the drawing board
Hmm.
and come up with something a little bit simpler.
Simpler. Well, not necessarily simpler, but definitely different. They've actually announced that they're now pursuing two alternative options. And get this, they're developing both of them simultaneously.
Whoa, hold on. Two options at the same time. So they haven't actually decided which way they're going to go yet.
Not yet. It seems like they want to explore both possibilities further before making a final decision, which is scheduled for sometime in 2026.
Okay, so let's dive into these two options because I'm dying to know what they've come up with. Option number one, what have we got?
All right, so option one involves a new style of landing, according to the article, but it's actually based on technology that NASA has used successfully before. Remember those amazing landings of the Curiosity and Perseverance rovers?
Of course.
Yeah.
Those were incredible. Like watching a rocket-powered sky crane gently lower the rovers onto the surface of Mars.
Exactly. So they're considering using a similar approach for this new lander. It would descend towards Mars with rockets controlling its descent, and then a sky crane would lower it down to the surface, kind of like a giant robotic claw gently placing the lander on the ground.
Okay, I can picture it. And it does seem like a pretty reliable method, considering its worked before.
Yeah.
But are there any downsides to this approach?
Well, there are always risks involved with landing on Mars. The atmosphere is thin, dust storms can pop up unexpectedly. It's a challenging environment. But I guess the biggest concern is that they're still relying on a single lander. So
Yeah.
if something goes wrong with that one lander, the entire mission could be in jeopardy.
Yeah, that's a good point. It's a lot of pressure on that one spacecraft. So what about option number two? What's the alternative?
This is where things get really interesting. Option two involves collaborating with private space companies.
Oh, wow. Like SpaceX or Blue Origin?
Exactly. Companies like those, they're really shaking things up in the space industry these days. And NASA seems to be recognizing their potential.
So NASA's basically saying, hey, private companies, let's team up and bring back some Martian rocks.
Pretty much. And this approach could have some big advantages, especially when it comes to cost. Private companies often bring new ideas and a more entrepreneurial spirit to space missions, which could potentially save NASA a lot of money.
Yeah, I can see that happening. But I also imagine there are some potential downsides to working with private companies.
Oh, definitely. It introduces a whole new set of complexities. For example, NASA would need to carefully vet their partners, make sure their technology is up to par, and navigate any legal or regulatory hurdles that might come up. It's a whole different ballgame compared to running the mission entirely in-house.
So it's a trade-off, right?
Yeah.
Potentially more cost-effective, but with added layers of complexity and maybe even some unknowns.
Yeah, that's a good way to put it. I guess NASA is trying to weigh all those factors as they move forward with both options.
And it's going to be a few years before we know for sure which way they're going to go.
Hmm.
Right? They're aiming to make that final decision in 2026.
That's right. So we've got some time to watch this unfold and see how both options develop. It'll be fascinating to see which one ultimately wins out.
Absolutely. It's like a space race. But instead of competing against other countries, NASA's competing against itself in a way to see which approach is the best way to bring those Martian samples home.
And ultimately, no matter which option they choose, the goal is the same: to get those samples back to Earth so scientists can study them and unlock the secrets of Mars.
Exactly. It's a mission that has the potential to rewrite the history books and maybe even change our understanding of life itself. So, yeah, I'd say it's worth all the effort and all the complexity.
Couldn't agree more.
Well, all right then. Now that we've got a good grasp on why NASA is changing things up and what those two new options look like, let's delve into the science behind this whole mission. What are we hoping to learn from these Martian rocks anyway? I mean, it's pretty wild to think about, right? We're talking about potentially holding pieces of another planet in our hands.
It is pretty mind-blowing. And what's even more amazing is that these samples could hold clues to some of the biggest questions about Mars and maybe even about life itself.
Okay, so let's talk about those questions. What exactly are scientists hoping to learn from these Martian rocks?
Well, one of the big ones is about the history of water on Mars. We know that Mars was once a much wetter place than it is today, and there's evidence that liquid water might have existed on its surface billions of years ago.
Yeah, and if I remember correctly, Perseverance collected those samples from Jezero Crater, which scientists believe was once a lake.
Exactly. So these samples could provide really valuable insights into what that ancient Martian lake was like. Was it a freshwater lake, a saltwater lake? How long did it exist? And were there any signs of life in or around that lake?
Well, okay, so we could actually be looking at evidence of a Martian lake bed billions of years old.
That's insane. It is. And by analyzing the rocks and soil from that lake bed, scientists can start to piece together a more complete picture of Mars's past climate and environment. And who knows, maybe we'll even find evidence of ancient microbial life fossilized in those rocks.
Wait a minute, hold on. Fossilized microbes? Like actual evidence of past life on Mars?
It's a possibility, however slim, and that's what makes this mission so exciting. We could potentially find evidence that life existed on another planet, even if it was just tiny, microscopic life billions of years ago.
Okay, you officially have my attention now. That would be a huge discovery. I mean, it would completely change our understanding of life in the universe, right?
It would be absolutely groundbreaking. It would mean that life isn't unique to Earth and that it might have arisen independently on other planets, which then raises all sorts of new questions, like how common is life in the universe? Are there other planets out there with more complex life forms? It would really open up a whole new chapter in our understanding of astrobiology.
I'm getting chills just thinking about it. So we could potentially find evidence of past life on Mars and learn about its ancient climate and environment. But is there anything else these samples can teach us?
Oh, definitely. There's a lot more we can learn from these rocks. For example, studying the composition of the Martian soil can tell us about the planet's geological history, how it formed, how it's changed over time, and what kind of geological processes have been shaping its surface.
So it's like getting a glimpse into the deep past of Mars, almost like a time capsule from billions of years ago.
Exactly. And all of this information isn't just valuable for understanding Mars, it can also help us better understand our own planet Earth, because Mars and Earth are both rocky planets that formed around the same time. Studying Mars can give us clues about how Earth evolved and why it became the life-supporting planet it is today.
That's a really cool perspective. I never thought about it that way. But it makes sense. We can learn about ourselves by studying our planetary neighbor.
Absolutely. And there's one more important aspect of this mission that we haven't touched on yet. It's not just about looking back at the past, but also about preparing for the future.
You mean like sending humans to Mars someday?
Exactly. Nikki Fox, the head of NASA's Science Mission Directorate, said that this mission will help prepare us to safely send the first human explorers to Mars.
That makes sense. These samples can provide crucial information about the Martian environment that we need to know before we can send humans there. Like what kind of hazards to expect, what resources are available, and how to protect astronauts from the harsh Martian conditions.
Precisely. It's like a dress rehearsal for a human mission to Mars. We can learn so much from studying these samples in our labs here on Earth that it will make future human missions much safer and more successful.
Wow, I hadn't really thought about it like that, but it's so true. This mission really is laying the groundwork for a human future on Mars. And it's all starting with these tiny little tubes of Martian rock.
It's pretty incredible when you think about it. And it's a reminder that space exploration isn't just about pushing the boundaries of technology, but also about expanding our knowledge and understanding of the universe.
Well said. So we've got this incredible mission that could rewrite the history books, change our understanding of life, and pave the way for humans to explore Mars. But there's another player in this space race, isn't there?
Oh, you mean China?
Yeah, that's right. They're also planning a mission to retrieve Martian samples.
They are. And they're aiming to launch their mission around 2031, so they're on a pretty similar timeline to NASA.
So it's like a friendly competition between the two space superpowers, except the prize isn't bragging rights, it's scientific knowledge. What do we know about China's approach? Are they doing something similar to NASA?
Well, it seems like they're focusing on a single mission to collect and return samples rather than exploring multiple options like NASA's doing.
So they're taking a more direct route. Interesting. It'll be fascinating to see how their mission plays out and whether they face similar challenges to NASA.
Absolutely. And I think it's important to remember that even though there's this element of competition, ultimately both NASA and China are driven by the same desire to explore and understand Mars.
Yeah, it's like we're all in this together, right?
What?
Humans from different countries working towards a common goal of unraveling the mysteries of the red planet.
Exactly. And I think that's a really inspiring message to take away from all of this. Despite our differences here on Earth, we're united by our shared curiosity and our desire to explore the unknown.
Well said. So we've got these two incredible missions on the horizon, both aiming to bring back pieces of Mars to Earth. And the potential for groundbreaking discoveries is just enormous. I mean, we could learn about the history of water on Mars, the possibility of ancient life, the planet's geological evolution, and so much more. It's mind-boggling.
It really is. And it makes you wonder what other secrets those Martian rocks might hold. What else could we learn that we haven't even thought of yet?
That's the beauty of exploration, isn't it? There's always the possibility of the unexpected, the unknown waiting to be discovered. And I think that's what makes this mission so captivating. It's not just about the science. It's about the adventure, the thrill of pushing the boundaries of human knowledge.
I couldn't agree more. And I think it's important to celebrate that sense of wonder and excitement because that's what drives us to explore, to innovate, and to keep reaching for the stars.
Beautifully said. Okay, so now that we've talked about the why, the what, and the who of the Mars sample return mission, let's dive into the how. How are they actually going to pull this off? I mean, bringing those samples back from millions of miles away sounds incredibly challenging.
You're telling me.
Hmm.
It's going to require some seriously advanced technology and a whole lot of precision. Let's break it down step by step and see how they plan to make this interstellar delivery a reality.
So we've got these tiny little tubes packed with Martian goodness just zipping around in space. How do we actually get them back to Earth without, losing them somewhere along the way?
It's definitely not a simple FedEx delivery, that's for sure. We're talking about a complex series of maneuvers involving multiple spacecraft and a whole lot of precise timing.
Yeah, it's like a giant cosmic ballet with millions of miles and billions of dollars at stake. No pressure.
No, not at all. But seriously, it is an incredible feat of engineering and coordination. So let's walk through it step by step and see how they plan to pull this off.
Okay, I'm all ears. Let's hear about this interstellar game of catch.
All right, so first things first. After launching from Mars, the capsule containing those precious samples is going to spend some time orbiting the red planet. It's basically like a Martian layover before the long trip home.
A layover, huh? So it's not heading straight back to Earth.
Nope, not right away. It needs to wait for its ride home, which is another spacecraft that's going to be launched from Earth, and travel to Mars to meet up with the sample capsule.
So this is where the European Space Agency comes in, right? They're the ones providing that Earth return orbiter.
You got it. So this European spacecraft is going to make its way to Mars, and then it has to rendezvous with the sample capsule, which is already in orbit.
Rendezvous.
Mm-hmm.
That sounds fancy. What exactly does that involve?
It's basically a very carefully choreographed space dance where the two spacecraft have to align their trajectories and speeds perfectly so they can come together without colliding.
I'm already sweating just thinking about it. These are two spacecraft traveling at thousands of miles per hour, and they have to sync up perfectly in the vastness of space.
It is pretty nerve-wracking, but NASA and ESA have a lot of experience with these kinds of maneuvers, and they've got some incredibly skilled engineers and pilots working on this mission.
Well, that's good to hear.
Yeah.
So once these two spacecraft are in perfect alignment, then what?
Then comes the really delicate part. The sample capsule has to be transferred from the Mars orbiter to the Earth return spacecraft.
Oh, wow. So it's like a cosmic handoff passing this precious cargo from one spacecraft to another.
Exactly, and they have to do it very carefully to make sure those samples stay safe and secure throughout the transfer.
Okay, I'm holding my breath just imagining it. So once the handoff is complete, then what happens?
Then the Earth return spacecraft fires up its engines and begins the long journey back to Earth, carrying those Martian treasures.
And those samples are finally heading home after their epic adventure to another planet. It's pretty mind-blowing when you think about the scale of this whole operation.
It really is. From launching rovers and landers to coordinating multiple spacecraft across millions of miles and then safely returning those samples to Earth, it's a testament to human ingenuity and our insatiable desire to explore.
And at the end of this incredible journey, those tiny tubes of Martian rock and soil could hold the answers to some of the biggest questions we have about the universe.
Like whether life ever existed on another planet, how Mars evolved over time, and maybe even clues about the origins of life itself.
It's like opening a time capsule from billions of years ago, a chance to glimpse into the deep history of our solar system, and maybe even learn something about our own place in the cosmos.
It's an incredible opportunity, and one that has the potential to change our understanding of the universe forever.
Well said. And you know what's really cool about all of this is that it's not just about the science. It's also about the spirit of exploration, the drive to push the boundaries of what's possible and to keep reaching for the unknown.
I completely agree. This mission is a symbol of human curiosity and ingenuity, and it's something that we can all be proud of.
Absolutely. So as we wrap up this deep dive, I'm left with a sense of awe and wonder about the incredible things we're capable of achieving when we set our minds to it.
And a sense of anticipation for what those Martian samples might reveal when they finally return home.
Exactly. It's like we're on the verge of a new chapter in our understanding of Mars and the universe, and I, for one, can't wait to see what discoveries lie ahead.
Me neither. It's an exciting time to be alive and to be following the incredible advancements in space exploration.
Well said. So until next time, keep looking up at the stars and keep wondering about the mysteries that lie beyond our world.
And who knows, maybe one day we'll be talking about human footprints on Mars, not just robotic ones.
Now that would be a deep dive I'd love to have. Thanks for joining us, everyone, and keep exploring.